Our next section is going to be section 7.2, and is going to be dealing with areas between curves. Oops. And it's just what it sounds like. It's going to be finding the area between two functions. So let's take a look. If we had our x and our y axis, and we have two functions, one function is going to look like this, and that's going to be our function f of x. And if we have another function, let's say looking like this, we're going to call g of x. And let's say we were going to try and find the area between A and B on the x-axis. Okay. So we're going to find the area within that region between those two x values and between those two curves, which would look something like this, right? Like this is going to be our region that we'll be finding the area between. Then we would calculate that area. A for the area will be equal to the integral from A to B, our leftmost boundary and our rightmost boundary. And then we would simply just be looking at the area where we subtracted function f of x, the top function, minus g of x, the bottom function, with respect to x. So again, it's whatever function is on top first, and then whatever one is on bottom is getting subtracted. Okay. Now, as you look at that graph, some of you may point out that there's area that's negative, that's underneath the x-axis, that should probably be considered negative. But if we considered those same functions, let me get rid of this here. If we considered those same functions so we have something that's on top here that was f of x. But what if I said, all right, let's move up f of x by, let's say, if we moved them both up 5 units, so that now each function is above the x-axis. When we would go to find the area from A to B, now we've got everything. It's still being the same area we're finding here. Now we've got everything above the x-axis. But still, in finding our area, we would now just do f of x plus 5 minus all of g of x plus 5. And what would happen with the two 5s would be 5 minus 5, and those would just cancel, and we'd really have the same thing as we saw on the previous slide. So one graph going below the x-axis won't affect this at all, because like we show here, we could just translate the two graphs up, and now when we subtract them, their constants eliminate, and we've got the same thing. Okay, let's show a more concrete example. So, oops, there we go. We're going to put a graph up here that's going to have a y-axis. It's going to have an x-axis. It's going to include the line y equals negative x. And also a parabola, something like that. It's not a very fantastic picture, but we're going to go with it. That's the graph of y equals 2 minus x squared. And the area we're going to find is the area in between those two curves. Okay? That's our section heading here, right? The areas between two curves. So we just take the integral of the leftmost point and go up to the rightmost point. And our leftmost point would be the intersection on the left side, which takes place, and I was a little bit off on that side, but it really would take place from -1 on the x is where they would cross. I was a little bit off there. To +2, still a little bit off there, but not as badly. And then those are our boundary points, our x values that are our boundaries. And now we're going to take the top function, which is 2 minus x squared. And from that, we are going to subtract the lower function, which is negative x. Now, before we integrate, we can simplify. So we have -1 to 2 of the whole function, 2 minus x squared plus x dx. The antiderivative of that would be 2x minus 1/3 x cubed plus 1/2 x squared from -1 to 2. And when we plug those in, the first value we would get would be it would be 3.3 repeating. And from that, we would subtract a -7/6, which would give us 4.5 units squared for our area. And so that is how you find the area between two curves.